Okay, friends, this is the solution for doubt sheet, revision sheet 1. Okay, the first question in some part of the universe, that question, mass is represented by m, speed by s, and time by t. Okay, so these three alphabets m, s, and t, they represent the physical quantities which those aliens might be studying. So the first question is about speed. Now it is very simple. Mass 0, uh, speed s, speed is there, so the power of s will be 1, and time will be 0. Okay, as because only speed s is there, so s will have power 1, and all the other fundamentals like mass and time, their powers will be 0. Okay, this is question 1 a. Now the second physical quantity, that is length. So what are we going to do in length? See the formula, see this formula, what is it? Speed is equals to distance upon time, or speed is equals to length upon time. So what is length equals to? Length equals to speed into time. Okay, now what to do next? Put the dimensions of speed and dimensions of time. What are dimensions of speed? m0, s1, t0, and dimensions of time t1. Multiply them, and this is what you get, m0, s1, t1. Okay, now coming to question number C, 1c, density. Go to the basic formula. Density is equals to mass upon volume. Okay, what is volume? Volume is equals to length into length into length. Okay, now what is length? What are dimensions of length? See, dimensions of mass, it's very simple. In the numerator, the dimensions of mass will be m1, s0, t0, because only mass is there, speed and times are not there. Okay, now length. What is length? Carry out this thing, the dimensions that we have already done this equation. Okay, you have to write at this place. So this is it, m0, s1, t1, and the power of that will be 3. Okay, because we have a power 3 over here, the power of this will also be 3. Got it? So this becomes this in the numerator, this in the denominator, open the bracket, so s becomes 3, t becomes 3. Solving this is what you get, m1, s minus 3, t minus 3. Okay, so this is what is a solution of question number 1. Now coming to question number 2. Now there are certain things in this. The answer, first read the question and then this is the solution. In question number 2, the answer is C, because time is a fundamental physical quantity. It can be measured and it can also be calculated. Okay, now the units of relative density. Okay, see the other quantities given in this question number 3 are unitless, but relative velocity is not unitless. Relative density is also there. Okay, now remember, what is relative density? Density of object upon density of water. It is in division. Okay, density of object divided by density of water. So the units in the denominators and numerator will cancel out, so it becomes unitless. But relative velocity, it is not unitless. What is relative velocity? Relative velocity of object A with B is actual speed of A minus actual speed of B. So when you subtract the unit meter per second minus meter per second, the unit that remains is still meter per second. Okay, so this is not unitless. Relative velocity is not unitless. Question number 4, when you check the dimensions, you have to analyze. Okay, you have to find the dimensions of LHS and then the dimensions of both sides of RHS. Okay, now when you analyze, these dimensions would not match. So this equation is not a valid equation according to dimensions. Okay, according to our calculations, it is 100% valid, but according to dimensional analysis, this thing is not valid. However, we will be using these equations for doing all our numerical problems and calculations also. Okay, moving to question number 5. 5 is equals to alpha ut. Okay, now here you have to find the dimensions of alpha. Okay, now what is S? S. What are dimensions of S? S is distance covered, so its unit will be meter. Okay, what is U? U is initial speed. So what are dimensions of speed? Is meter per second. And then time. What are the unit of time? The unit of time is seconds. Okay, now what you do is transpose everything else on one side and let alpha remain on one side of equality sign. So on one side we have alpha, on other side we have meter cancelling with meter, second cancelling with second. So what are the unit of alpha? The unit will be, there will be no unit. It is a unitless quantity, and so its dimensions, if someone asks, what will be? M0, L0, T0. Okay, now question number 6, relative density and density. Do they have the same units? No, the unit of density is kilogram per meter cube, while relative density we just discussed, relative density is unitless. Okay, now see what you're going to do in question number 7. It is rate of change of acceleration. To the language, rate of change of acceleration. What you do when I ask the rate of change of anything? You divide that anything by time. So rate of change of acceleration means acceleration divided by time. Put the dimensions of acceleration, then put the dimensions of time, and this is what you get. M0 L1 T minus 3, rate of change of acceleration. Actually, in the language of mathematics or the language of physics, we always say that whenever you are asked the rate of change of something, okay, the rate of change of something, then just divide that something with time. That's all. Now coming to question number 8. It is pressure gradient, just like rate of change is dividing by time. When asking about the gradients, this one, gradient. What is gradient? When someone asks you gradient of anything, divide anything by that anything by distance. So whenever this word gradient is there, pressure gradient, so we have pressure and we have divided this with distance. Now again, if you do not know the dimensions of pressure, you can again find out as pressure is equals to force upon area. Force upon area upon distance. Now the dimensions of force, you must be remembering that. Okay, M1 L1 T minus 2, the dimensions of area L2 and the dimensions of distance L1. Just go for mutual solution of this, and finally what you get, the answer, it is this. Okay, this was question number 8. Now coming to question number 9, advantages of dimensional analysis. We can know the basis of the basic ingredients of the qualities. Okay, it's the basic it's not basic, it is we can know the basic ingredients, BASIC, the basic ingredients of any physical quantity. Okay, then we can compare the quantities. This is second advantage. The first disadvantage, different quantities can have same dimensions. Okay, you have work and potential energy and kinetic energy and torque. All these things are having same dimensions, but they are different from each other. Okay, second disadvantage, some quantities are dimensionless, like relative density, density, everything. Okay, so these are advantages and disadvantages. Now coming to the last one, the dimensions of G, where what is G? G is this universal gravitational constant appearing in the universal law of gravitation. This is G. Okay, transpose everything else onto the other side. R square, send it here, masses, send in the denominator. Okay, and this is what you get. Okay, now put the dimensions of force. This is dimension of force. Put the dimensions of R square, that is L2. Put dimensions of mass, that is M1. Put dimensions of another mass, which is again M1. Just go for a solution, and this is what you get. Okay,